Back in a conference. It seems like it's been forever for most of us, and so it's great to be here. And for those of you, many of you do know Madhav. He sends his hellos and regards and wishes he could be here as well. And he just had a last minute family thing that came up and was not able to come. What I want to talk today a little bit about is some of the technologies that we have opportunities to use, and what and why we should be using them. I want to introduce to you a couple of different models. One is called a technology maturity, and the other one an intelligence maturity. And it's a way for us to be able to identify what are the right technologies for us at any moment in time. And then I'll share with you a use case of a project that we were working on that Madhav has been directly involved with. So for whatever reason, we've all chosen to be in this industry that's pretty hard, pretty complex. It's really booming right now for many of us, and as has been mentioned, it's we're going so fast at such a high pace that it's hard to get away. It's hard to get out and do these kinds of things. But in the day-to-day operations, our goal is to find different ways to build it right and fill those orders and try to keep our customers happy. And for whatever reason, we decided that semiconductor was the path, and there's a lot of complexity that exists in it. As one of the big challenges that we face regularly is when we get those new products introduced and we get into this high volume state. Often our management comes to us and says, I need you to figure out a way to do it for less cost per die. Find a way to get more out, or find a way to reduce that cycle time, or whatever your objective is at that point. They want more. And that's led most of us to start looking at some variety of technologies. There's a lot that's out there, and the opportunity as you use these is great if we can figure out how this works for our business, and whether it's the working in the cloud or big data, or any of these other things that give us a benefit. We need to find the right way to sell and pitch this to our management, help them be a co-visionary with us, and so forth. As we go out in the industry, we're constantly working with different companies. Many of you we work with, talking to different companies about some of their challenges as well, and the common things that they are faced with as they try to adopt these technologies are things like adoption in isolation. They get something working really well, but it's not necessarily working really well with the rest of the fab. And so, I heard a famous saying once that progress is defined by everybody taking one step forward. And it's not defined by having somebody way out there that's left everyone behind. And sometimes that happens in our pilot programs and so forth. Security is huge. How much do I want to put out on the cloud? Do I trust putting it, into a public cloud, and take advantages of some of the benefits that exist there? Data quality. When you start to aggregate systems that are disparate, that are independent, you're always going to find data quality challenges. And maybe the biggest one is the fear of change. If we go do this new automation thing, what's going to happen to my job? If I'm a executive at a company, am I willing to risk my last few years into something new that, maybe at the executive level, they don't really understand it, they don't really know. And so a common theme that we have seen and learned from those who have succeeded and those who have struggled is that you not only have to have a technology visionary, but you have to have a business vision as well. You cannot be very successful if all of your vision is from the technology side and there's no executive support. And you also cannot be successful if all of the vision is at the executive level and you don't have the technology involvement along the way. We often get asked about, what does Industry 4.0 mean to you? And we have to distill it down to business objectives. And the business objectives for us, when we think about, are about smart manufacturing. And we define that in two simple ways. The striving for zero defects, may never get there, but we're going to try, okay? And optimally using the assets for predictable output. Just a quick definition of each of these so that it gives a little more context. There's a couple axes of interest here. One of those is looking at what is the capability of my process, and am I under control with my process? And secondly is, what is my capability of automation? And as we're able to move both of those things forward, we're going to be able to move closer to the zero defect objective. Many of us today still work with systems that are offline, and the data is where it's disconnected. We can only do so much as humans along the way. As we move up this scale and start to introduce systems into our fabs that can make decisions humans can't, we can take another step closer to zero defects. And ultimately, as we have massive amounts of data and historical information, we can start the process of learning. And through learning, we're able to introduce AI principles. And this is with an objective of taking us to end-to-end quality and try to work through the supply chain with some of our partners as well. On the assets, there's so much variability in our fab, whether it's people or equipment or the supply chain, which is a huge challenge for all of us right now. New products introduced, the product mix that you have, these all have an influence on our operational characteristic curve that so many of you are familiar with. And this, in essence, just it plots out, at any point in time, am I trying to have my, move the whip through my fab at a high rate so that I can increase my output, or am I trying to be optimal with the whip that I have and keep that cycle time really low, keep my inventory low? And I think that changes from time to time for different fabs. Moving this curve to the lower to the right, that's what your management's asking you to do, to get more out of what you have. I want to change the tone a little bit for just a minute and talk about automated vehicles. Probably most of you in here, maybe all of you in here, have been in these automated vehicles before. I remember the first time I got in one, I'll be honest, I was a little bit nervous. I wasn't sure if it was going to stay within the lanes when I let go of the steering wheel. I wasn't sure it was going to stop by itself, and I wasn't sure if it was going to turn by itself. And I was kind of nervous as it has all the sensors making decisions in real time, and it has to understand the boundaries both in the road and the boundaries out of the road to keep people safe. If something goes wrong, it can go really, really wrong for us. And so the relationship or the similarities behind what is required to keep an autonomous vehicle on the road and manufacturing automation in the fab are very, very close. The Society of Automotive Engineers created a definition that I'm going to talk about in just a few minutes, and it's really close to what we do in manufacturing. But it starts with our decisions and how fast we can make those. And the main objective here is, to reduce that time of the decisions of when an event occurs until the decision can occur. And to do that, of course, you've got to have data, you've got to have a knowledge base, you've got to be able to have applications that are intelligent, that know what they're doing and know what kind of decision to make. Well, there's a couple challenges that we face here. And one of those is that technology is continuing to mature, okay? And the applications that have intelligence in them are continuing to mature. So these are two limiting factors that we face in automating our factories. So as I mentioned, I wanted to take a look at this model that was created that so applies to the fabs that we work in. And it began, in the early days, right, where there was no automation. We would carry whip to a tool, we would start the equipment, we would take our notes, we would then go run around the factory and find the next task that we individually had to do. It was all manually driven. The next step of automation, which also is initiated by a person, started to use systems in the fab, things like material handling, things like checking some of the advanced process control, some of the early days of that, started to use systems to aid us in the manufacturing process. When you move up to level 2, you start to see those systems working together. They're not just working by themselves. So things like tool-to-tool delivery, and I guess I jumped the gun. This is where you start to see advanced process control and so forth. So these are all initiated still by a human, right? And so they're subject to the speed that a human brings to the table. Well, there's a desire to do something better, and the opportunity to do something better. And these upper levels are different levels of what some may call full automation. But we hit a wall. We hit a problem here, and the problem is proving out the technologies that we kind of listed before. And I want to show you just an example of how far they've come. Now, it wasn't very long ago we all lived in a world with 3G, and I don't know about you, but I like movies, and I like to download my movies, right? When I take a flight or whatever. One of my favorites is The Avengers. And so one of the things I looked into is how long in 3G would it take to download the Avengers movie? And what I learned was it would take about 27 hours, about the time to get checked in and fly from Dresden to Sydney, Australia. Well, 4G was a huge improvement, a huge step forward, okay? You could download that same movie in about 6 minutes. That's about as long as running a mile for some of you, not for me, right? And so when we move up to 5G, it's about as quick as saying, is it downloaded yet? So the stepwise increase in this technology is something that we'll be able to leverage in the future. Similar other technologies like this, if you think about comparing a CPU to a GPU, it's something to the magnitude of 50 times more powerful. And now we see on-board, on-chip AI technologies that are talking about increasing it that much more. Companies like Cerebus and Sentient and so forth are working on those kinds of technologies. When we get into data, we're talking about petabytes of data. That's 15 zeros. That's a whole lot of zeros. And so the opportunity is huge to take advantage of that technology. For me, I think of this automation level 3 as a proving ground for these new technologies. The blue automation levels really mean that it's a system that initiates the actions. It's a system that reacts and then continues to close the loop on an action to try to reduce that decision time. And we're kind of in that proving ground right now. Taking a step forward to level 4, which is a high level of automation, is when you start to see AI come into play. And this is, in this scenario, it means that the system, the collective system that you have, will be able to recognize and do things that maybe it has not encountered before, okay? So when I think of AI, and when most think of AI, it's about how do I make a decision that I haven't come into before, and having the learning to be able to make that kind of a prediction. And then level 5, I don't know if we'll ever get there or not, but level 5 is about making those decisions in a situation I've never seen before 100% of the time, okay? Level 4 is only part of the time. So there's a stepwise opportunity there. I want to talk next about the intelligence. Intelligence comes from integration. Today we operate highly in a sensory way, kind of unitary systems that see a problem, fix a problem, and then move on. See another problem, fix a problem, and then move on. And that's the way our fabs work in a lot of ways today. If you take the next step to peripheral intelligence, you're talking about looking one step up, one step down, the chain here, the processing chain, and being able to solve a common goal between two different systems that are in a finite processing area. Taking another step forward, we call it interdependent intelligence. And what this is many systems working together to solve a common problem. This is an environment of learning at this level. As you move on up the stack, the next is probabilistic intelligence. This is taking the learning that we had and having the applications to do things like AI and make those kind of decisions that we spoke of a moment ago. And lastly is we call interpretive intelligence. This is about having full cognitive capability. And again, whether we ever get there or not, I don't know. We're still trying to struggle moving up the lower to mid areas in most of our manufacturing right now. And so if you were to overlay these, let's see, there's a pointer on here somewhere. There it is. Oh, that's a really light red pointer. To overlay these are the intelligence maturity steps that overlay the technology maturity steps. So I want to take a minute and kind of move in another direction and share a use case that we've experienced that kind of connects to the model that we just talked about. So we'll talk about the problems, how we addressed it, the results, and the conclusion. So this is an assembly and test factory. This one's based in the U.S., and they have had growing challenges that they've never seen before. Their bill of materials was growing out of control. They were not able to deliver to their customer on time. They had long wait times, and if anything was changing, and things were always changing, both on the shop floor and in their supply chain, and as those changed, they were not able to react in their factory to be able to address them. The accuracy of their plan that they created was relatively poor, in their words, and it was leading, again, to not being able to deliver on time. So ultimately, their management came to them and said, our customer satisfaction is down, equipment productivity is down, cycle time is up, and things are not in balance here. We have a problem as their costs started to rise. And so we sat down with them and we said, okay, well, these are some of the things that we have been working on in this same area. Let's talk and see if these architectural elements work. And so many of you are familiar with our APF platform that has RTD and Activity Manager and scheduling and so forth. Those are some of the assets that we used here. And so it really begins up front with how do we get the data together and how do we leverage that data. So this particular customer, we're pulling MES data. We're pulling data from their ERP. They have equipment data that is feeding this, kind of rudimentary equipment data, mostly equipment states, and a series of flat files that had, in whatever format, the data. So we're uploading all of this. Now we have a problem. The problem is the data is disconnected. And so that's where this transform and validate state really come into play. And so at this point, we're taking the data and we're transforming it into a common standard that we've defined together. We're validating it that it's meeting that standard, and in some cases where there's gaps, we're able to fill the gaps of that data. The purpose is to get ourselves to what we call a common data model so that we can start to make decisions together. So once we have the data in the common data model, then we have the applications that can operate on it, whether it's dispatching or planning or scheduling or whichever one of those that are needed in this case. We have this term called engineered works. You may have heard of it. That just simply means it's pre-built logic for a specific operation in a fab. Most of you who have familiarity with RTD and Activity Manager kind of look at it as a toolkit. I get a toolkit, I go build my logic, and this has got some pre-built logic. And then over on the right side is our UI. It's the way we configure. It's got our dashboards. We're near a release of an advanced analytics package and so forth. So we started to use that in this particular project. At the application layer, the application design, the scope included planning down through dispatching, again using a common data model. So I'll take just a minute and start on the right side. Let's get right into the fab first. Dispatching, many of you are quite familiar with. It's making a decision at a point in time where we decide what to process on a tool type or a set of tools within a tool type. So that relationship is many lots, right? Selecting from many lots to one tool type to one moment in time. It happens in real time. The difference in scheduling is it looks over a time horizon and it looks across a whole nother set of tools. And so the scheduling is a many to many to many in terms of number of lots, tools in the fab, and points in time. We have a prediction engine that we're using to be able to see where's the WIP going to be in an hour, where's it going to be in 3 hours, where's it going to be in 6 hours, in 12. And that's allowing us to be able to make better decisions on the shop floor. Scheduling and dispatching work together. This particular customer had none of it, and so we started with dispatching. Now let's take ourselves out of the fab and into the planning area. The long-term planning that we're doing with them we call it unconstrained. It's basically how much business can we get in and what fabs can we have go do this business over the next year, and do we need to accelerate that new factory, or do we need to use an OSAT to be able to meet all of these customer demands? The next level of planning down, we call it short-term capacity plan. It's roughly across a 6-week horizon, and it gives us a forecast that says, okay, you can take Fab A and allocate this based on its tool count, how many wire bonders, in this case, it's assembly and test. How many wire bonders does it have? How many load boards does it have, and what are all the constraints? And a lot of customers out there are taking that and feeding it right into the fabs or into the factories to be able to do that work. What we've added here is something that we've been working on for some number of years. We call it production control. And its purpose is to go run scenarios and say, okay, I have a plan. Is it going to work? And what's built into those scenarios is the same logic that runs out in the fab or the factory. And so it uses the same data, uses the same rules. And so the simulation is going to be much more accurate than most simulation that's done outside of a factory. So from that, we're using inside of it, we're using an optimization engine. So it takes the fab model, converts it to a mathematical model, and looks at different ways to solve the problem, then brings it back to a fab model and picks the best one. That's how we arrive at a 6-week commit plan, which goes into the daily plan. So this was the design of the applications for this particular case. As we rolled this out, and the data flow kind of moved through, of course, we're grabbing the data, we're going through and validating it, checking for errors, seeing if there's something that the blanks that we need to fill in and so forth. And then we run it through the execution engine. Now this actually represents 3 execution engines. One of those for planning, which is based on optimization technology. One of those for scheduling, which uses simulation to do the prediction of the time horizons, and then dispatching is done heuristically. Then we get over to the output, the blue box in the output. That's actually where something good is happening to the die. It's being bonding, or it's being cut or packaged. And then looking at the results, which we have in various reports and graphs and diagnostics and so forth. So what is it doing for them, right? It's one thing to have a project, but you want to always be measuring yourself. And we're still in the early stages of measuring what they're getting. But one of the things that they're starting to see is the capacity increase. So that characteristic curve we looked at earlier is starting to push lower and to the right. They're getting more out of what they have. What we've seen in semiconductor front ends and in some of semiconductor back ends that have done this is a 5 to 10% capacity improvement. And they're starting to see that come along. The next thing is their planning stage is faster and more effective. Historically, they spent about a day just prepping all of the data before they started their manual planning, and now that comes through the data transformation layer, and so they're saving a day there. It took their planners about another day to get that 6-week forecast, and through the optimization capability and so forth, it's taking them about 2 hours to be able to evaluate all the different options that they're able to take and arrive at the best plan that they can implement. The accuracy of their plan is showing good results. That's measured by, am I meeting my customer commitments? And this is something that we're in the early stages on this particular project of measuring as well. What we've seen over some of the other projects is a 3 to 5% improvement on those commits, and we're starting to see that here. And then, of course, it's making decisions on the dispatch floor or on the shop floor in seconds rather than waiting for a human to go make a decision. Just in conclusion, the thing that we've been able to work through is using a single common platform. So our customer here in this case is using something that they've grown to be experienced with. The data is being integrated. The accuracy seems to be going in a positive way. And they're remembering that as they make these updates in the factory, that their business processes, corresponding business processes, need to be reevaluated to see what kind of change needs to be made there. They've basically taken a step to increase their intelligence maturity really up to that interdependent level. So hopefully this made sense to you. You may have heard some of the problems that you're facing today, and I thank you so much for the time and letting me share this story with you and some of the views and visions that we've created as we've talked to many of you and many of our customers over the last several months. So with that, Steve, is there